Okay, good day everyone. This is teacher Justina, and for our video today, it's all about graphing a linear equation into variables by slope-intercept method. But before that, we should have to recall the slope-intercept form of a linear function or a linear equation. So it is being represented by y equals mx plus b, okay, in which the m is said to be the slope and the b is the y-intercept. So suppose you're given an equation y is equal to 3/4 x plus 2. The 3 over 4 is said to be the slope. So if it is the slope, then what is this 3 means and the 4? So the 3 means the rising and falling, and then the 4 refers to the run. So when we say slope, it is the rise over run, or it is the way the line slants. Okay, so before an example, let us familiarize the following slope of these lines. Okay, for a horizontal line, its slope is 0, while a vertical line, its slope is undefined. Why undefined? Because as you have seen the line, we cannot tell as to where this line slants to. It's either left or right. So that is why slope is being undefined. So what will happen if a line will be slanting to the right? Okay, so if it will slant to the right, the slope is always positive. So for that line, it obtained a slope which is positive. Okay, what about if a line slanting to the left? So remember that if a line slants to the left, it is always having a slope with negative. Okay, so let's proceed to an example. Given an equation y is equal to 3/4 x plus 2. As you have seen, the given equation is already on this form. Thus, our m there representing the 3/4 as our slope. Okay, while the 2 there is representing our y-intercept. So what shall we do first if we are done locating the y-intercept and the slope? First thing to do is to plot the y-intercept. So we knew already how to plot the y-intercept. So it is the point where the graph crossing the y-axis. So 0, 2, it's the y-intercept. Next, since we will be determining a line out of 2 points, so we need to have 1 point more to have a line. So what is our next move? Okay, from the slope which is 3/4, the 3 there representing the units in y, rising, or it is a rise, no? And then what about, okay, so the 3 there meaning why it goes up, because 3 there is positive, so that means from the y-intercept we need to go up 3 units. So 1, 2, and 3. So we will not make a point in there because we have to temporarily stop in there. Because how to locate the next point is to consider the run in the slope. The 3/4, so the 3 there is the rise, the 4 is the run. So since the 4 there is positive, thus we need to have a horizontal distance 4 units. So we have 4 going to the right, 4 units going to the right. So we have 1, 2, 3, and 4, and there the next point. So the next point is being named as 4, 5 as the ordered pair. So we are done plotting the 2 points already because our title there is graphing a linear equation into variables by the slope and the y-intercept. So we have done the y-intercept, and by following the slope, the rise over run, we're able to get the next point. So we can now plot, not plotting, but connect the points now. So connecting the points, so that's it. And now, how do we know if our graph is correct? So as we used to from the first video, we need to check one of the points on the line. So we have the 4, 5. Thus, we have to use the original equation y equals 3/4 of x plus 2, in which the y is 5 and the x will be 4. So since we will be isolating the 4 there, thus we will be canceling the 4 over 4 because it answers 1. So therefore, that will be cancelled because it equals 1. And so far, 5 is equal to 3 plus 2. Okay, so therefore, 5 is equal to 5, meaning our graph is correct. Let's proceed. So therefore, be reminded that our slope is positive. Why it's positive? Because as you have seen our line, this line is slanting to the right. Okay, let's proceed to another example. Given an equation, 5y plus x plus 10 is equal to 0. As you have seen, it is not on its slope-intercept form. Thus, we are going to adjust into this form. And since the y has a 5 as a numerical coefficient, then we need to isolate it. So isolating it, we have to divide all terms by 5 in both sides. Thus, we are now having a y is equal to negative x over 5 minus 2 because 10 divided by 5 is equal to 2. And for this, we're able to get our slope, which is negative 1/5. Remember that there is a 1, an imaginary 1 beside x. So therefore, getting the slope, we are into the numerical coefficient, do not include the variable. And for that, our y-intercept is equal to negative 2. For our slope, negative 1/5, we are going to find out. So since it's negative 1, so we need to go down. It's fall because the y units is said to be the rising and falling. Then the 5 is said to be 5 units run because it's positive going to the right. So let's proceed plotting the y-intercepts, which is 0, 2. Okay, and then after which, locating the next point, we need to consider the negative 1 as it goes down because negative 1. So from the y-intercept, so we go down 1 unit. And to proceed to the next point, we need to consider that our run is 5 and it's positive. So it goes right. So 1, 2, 3, 4, and 5. And there is the second point. So the point there is already plotted as the second point. And it's now 5, negative 3. Now, how do we know if our graph is correct? So the 5, negative 3 is on the line. Thus, we try check using the original equation. So 5y plus x plus 10 is equal to 0. So instead of y, we change it into, instead of y, we change it to negative 3 and our x will be 5. So therefore, negative 15 plus 5 plus 10 is equal to 0. And thus 0 is equal to 0. And so far, the slope is negative because as you have seen, the line is slanting to the left. Now let's proceed to this example. Another example is having a y term which is a fraction. But still, we have to adjust this into this form. And remember that a y should be alone with a positive 1. So how to isolate the 2/5 there? So actually, there are other way other than this in isolating the numerical coefficient of y, which is 2/5. But let us have this process. Okay, multiplying both sides by 5 is uh, having this next equation now because 5 and 5 will give you a 2y and then the 5 will be distributed so 5x and then 5 times negative 4 will be negative 20 and still we were not able to come up with this form. So because there is still a 2, so therefore we need to apply division property of equality by dividing both sides by 2 in order to get the y exactly. So the y now is equal to 5 halves x minus 10. And for that, our slope is 5 over 2 and our y-intercept is negative 10. And then for our y units, it's positive. So we will be rising 5 units from the y-intercept. And therefore the run will be moving 2 units to the right. Let us plot. So we will be expecting that our slope is positive. So we'll be expecting that our line will be slanting to the right. So plotting the 0, negative 10, that's it, the y-intercept. And since 5 is our uh, number of units, the 5 is the number of units to go up. So 1, okay, that's it. And 1, okay, so where is it? So we have 1, 2, 3, 4, and 5. So we temporarily stop there. And since the run is 2, we need to go to the right 1 and then 2, and there is the second point. So to connect the point, okay, so the name of the point is 2. It's 2 and then negative 5. So plotting it, that's it. We are now connecting the 2 points, and the same thing, we need to check if our graph is correct using the 2, negative 5. Using the original equation, 2/5, and this is our y, and our y is negative 5 is equal to 2 because our x is 2. So therefore, you know that 5 and negative 5 can be cancelled. So therefore, it is now negative 2 is equal to 2 minus 4, which is negative 2. Okay, so far, the left term is equal to the right term. Okay, and here is our next example. You're given an equation. Negative 3/4 y minus 1/2 x plus 2 is equal to 5/4 y. We are to adjust them into y equals mx plus b, and thus we will be gathering similar terms. This one and the other one are similar, thus we have to write them together, and that's it. We have this one, and then next step is we are going to combine the negative 3 and the negative 5, and they have the same denominators, so therefore we have negative 8 over 4. Okay, and then rewriting the negative 1/2 x plus 2 is equal to 0. And then we have to leave the negative 2y on the left, and this is the simplified form of negative 8 over 4. And then we are to transpose the negative 1/2 x and the positive 2 to the right, and it is now negative 2. And then to isolate the negative 2, the numerical coefficient of the y, we need to multiply the reciprocal of negative 2, which is negative 1/2. Thus, we are able to multiply the negative 1/2 both sides, and for that, we're able to have the negative 1/2 times negative 2y. It is now y equals negative 1/4 x plus 2 over 2. And simplifying further, the 2 over 2, it is now 1. And so therefore, our y equals mx plus b form is already y equals negative 1/4 x plus 1. And for this, we have already our slope, which is negative 1/4, and our y-intercept is positive 1. So therefore, we are now to plot the y-intercept, which is 0, 1. And then after which we are going to look for the next point by considering our slope. And since it's negative 1, this is negative 1, that means we need to move 1 unit down. And since our denominator of our slope is 4 and it's positive 4, thus we need to go to the right 4 times. 1 unit, 2, 3, and 4, and there is the second point, and the point will be named 4, 0. We will now connect the 2 points, and then how do we know if our graph is correct? Thus, we're able to check the 4, 0 as our testing point if it will satisfy. So checking for 0, we will be changing the x by 4 and the y by 0. So negative 3/4 y, it is already negative 3/4 times 0, negative 1/2 times 4, plus 2 equals 5/4 times 0. And to simplify them further, it is already, okay, negative 2 plus 2 is equal to 0. Thus, 0 is equal to 0. And since They are equal, meaning our graph is correct. Okay, so for the next video, please try visit my YouTube channel. I'll be discussing graph of a linear equation by table of values. Thank you everyone for watching.